Welcome to the Boulevard of Broken Things. So, yeah, these are two ESP32 modules, and there's a little bit of guilt associated with these guys because I convinced the powers that be at the school that I work at that they would benefit from having these in the science department, which, to be fair, they have. They ordered 10, and there was some automated agricultural watering measuring thing that seemed to work out okay. They're not using the IoT part of it yet, so I don't think they're using the Wi-Fi or Bluetooth capacity of these. They're just using them as microcontrollers, and pretty handy ones they are. So 10 of them ordered, 8 working fine. These two, not so much. So if we plug them in, they just take a little micro USB at the end, which, yeah, could be part of the problem. Who knows? This one, dead. And this one, also dead. I think at one stage I thought one of them had a light on it you could see, but I don't think I'm even seeing that at the moment. So I guess my first thing is, are they getting power? So we can test. The power coming in is 5 volts. This guy obviously takes 3.3 volts. And here's our AMS 1117 3.3 converter. So it's possible that could be a problem. It could be the micro USB, perennial problem with those guys as well. We can have a look and see if there's any hotspots on them. I'm guessing that, it's possible to maybe, decan them, because they do have cans over the microcontrollers inside. Presumably that's part of certification. I don't really know. But in any case, we can check a few things. I'm loath to throw things like this out, even if I could harvest the AMS 1117 3.3 volt regulators. That could be a win. So yeah, a little bit of guilt associated with that. If we can get them going, that is fantastic. If not, 8 out of 10, that's not such a good thing, is it, when you're buying? I haven't had that problem buying from AliExpress, and I'm slightly concerned that that's what's going on. These two, on the other hand, I will take full responsibility for. So in the middle of making a Kim Uno project, so here's my delightful Kim Uno, and on the back is an Arduino Pro Mini. There's all sorts of different varieties of these, and one of them is I think it's 3.3 volts, but 16 megahertz. All the ones that I've been able to use, including this one, is 8 megahertz. So that worries me a little bit. And I keep ordering from different suppliers, hoping to strike Nirvana, a 3.3 volt and maybe 16 megahertz version, or even a 5 volt 16 megahertz version would do as well. So what I did ill-advisedly was to muck around with the fuses and the bootloaders on these two, and I think I've pretty much cooked them. If you have a look, you can see that there are little crystals here, and they've got markings on them which would indicate nothing of any use to me anyway. I haven't been able to find anything online about them, but presumably they're probably 8 megahertz. And so what I could do, there's two choices with trying to fix this. One of the ones I'd like to do is maybe take this one, where this is a bit more accessible, and pull this one off, this presumably 8 megahertz crystal oscillator, and put on a 16 megahertz. I think I've got a 16 megahertz crystal. Yeah, it's not SMD. I'm not even sure that's 16 megahertz. It does say 16 on the top. I have a test around here somewhere. Yes, I do. Let's get the Uno out of the way. Let's put this in here. I think this is the one that I built a long time ago and has proven itself useful from time to time. There's a battery. I'll link the video up to the build for this. It's pretty cool. So if this is working, yeah, look at that, 16. I hope you can see that. It's not always terrific via the camera, but that is bang on 16.000. So I'll take that. So one possibility then is to get rid of the SMD version of this chip and replace it with a 16 megahertz. The other thing is, if this is completely cooked, and maybe I'll do it with this version, I can maybe remove the Atmega 328 and put it in my handy dandy fuse zapper. And again, I bought this a long time ago. I don't think I've ever done a video on it actually, but it has saved my bacon a few times, because particularly with the A-Tiny13 and the A-Tiny85, which slot into here, I was forever mucking up the fuse settings and, initially at least, throwing away the chips. But if you've got something like this, it's called a high voltage, I think it says SP, HVP is what I've mostly seen them as, which is a high voltage programmer. But basically that means that you can put your chip in here to recover. You press the button here and great things happen. And I'd be taking, let's say, this one out and putting it into this space here and seeing if I can burn the fuses before I put it back in. And I know that each of these things is only worth, I don't know, $3 or $4 or something like that. But it just gets my goat that I've burnt them for no apparent reason. So I'd like to try and recover them and go from there. Yeah, so let's get started with the ESP32s and see if there's any power coming in. Right, that can's a wee bit shiny, but anyway, that is life. So let's get this guy switched on, and this is not the most accurate beast in the world, but that's okay. And let's get some power. So I'm guessing that we should be able to see some voltage coming in, and so we've got 5 volts coming in, which is a good sign, and then we've got coming out of the AMS 1117. Ooh, nothing. Now maybe that's because of the components around it. Maybe there's another failure there somewhere. We don't really know that. There's also a V in and ground here. Is there a 3.3 out? Let me see. I think I've got, did I write these down? Somewhere I think I wrote. Yeah, it looks like 3.3 volts on the other side. Oh yeah, I can see it there. Okay, so power back on again. This will turn itself off if there's not much happening. So let's go back to ground, and over here, do I get 3.3? No, that is not a good sign. So whether it be the, I don't think it's the micro USB, because we wouldn't be getting 5 volts on here if the micro USB wasn't supplying it. But the fact that we're not getting 3.3 volts here means that I'm going to replace the AMS 1117 and see what happens. Let's do that. So here's the new AMS 1117 3.3. So let's get rid of the old one, the old air gun, and see what happens. So hopefully this will be fairly straightforward. I mean, you can't make it worse, right? If it doesn't work, it doesn't work. I'll try not to burn the hairs off my hand either. Just put a little bit of gentle upward pressure on that and see if we can't encourage it to lift off without lifting the pads. So yeah, that's the gentle pressure needed. There we go. Look at that. Beautiful. Okay. So I might clean that one up and solder on the new one. So that's nice. All right, so let me just see if I can clean up these pads a little bit and just put some more goop on there. And then we can see if we get the new one on there. Don't know that we need to be actually suspended in the middle of the air. That's sort of making life a bit tough. Let's put it back in this breadboard. Try that. That's very satisfying. Try and refocus if we can. And then we put some, yeah, that's nice. Just a little bit here. And a little bit here. And then new guy. Hopefully I haven't got those confused. That would be hilarious. Probably should have thrown that straight back in the bin, I guess. All right, so let's see if we can't reattach. Oh, that's a big dollop of solder we don't need. Nice. I'll have a look at this under the magnifying glass, but that looks pretty solid. Maybe a little bit more goop on this side. Yeah, nice. Okay, let's have a look at that and then we'll fire it up. Moment of truth. Let's give it some juice. Did you see that? Can you see that light? Can you see that light? Oh my God. Surely it's not that simple. Let's have a look. So we'll just put this one on here. And from memory, that was 5. Let's try again. So that's showing 1.7. Interesting. And this one? Nothing. And this one? 3.3. Look at that. And our one over here is at 3.3 out. It's still not, is it? I still can't see a clear 3.3 out on this pin here. There's a ground next to it. I think that's a ground there, if my eyes don't deceive me. Let's try that. 3.3. Look at that. Wow, that's pretty impressive. So, yeah, little guy was not well. Next thing is, can we actually program it? So we'll have to take it upstairs to see that one. But let's test this one now that we're. That's so good. It'd be nice to recover that. And such a simple thing. Those little AMS 1117 3.3 volt regulators are cheap as chips. Okay, so we've still got power coming through. Let's see if it is a similar thing. So there's our ground here. And 0.84 is not good. And what are we getting here? 4.2. I don't know what that's about. And nothing. And nothing. Oop, and then we're out of power too, which doesn't help. Let's try this one. Yeah, so not good values anyway. Another little AMS 1117 3.3, and well, is it that simple? Anyway, let's solder the other one up. Here we are with our victim. Hopefully it's going to program. I've just got a blinky up here, so we'll just see if it will compile and load. All the standard settings for an ESP32. And okay, so it looks like it doesn't know what built-in is for this board. So I'm going to go with something like 0 and see if that will work. I'm not sure what the number of the actual onboard. Oh, look at that! We are programming. We are programming, and we're resetting, but that is not blinking. So let me get back to you, and I'll put a we'll see if we can put a little LED in there and get that actually blinking. But that's at least programming, which is a huge win. Right, so I've just had a look online and found out that the inbuilt LED, or built-in LED, however you like to say it, is pin number 2 on these development module boards. So let's try that and see if we notice anything different. It's uploading. That's a good sign. And there's a blue light blinking. Oh my God! All right. So listen, while we're in, let's get the other victim in. So I'll take this one out. This is the other one, and I'll just whoa. Okay, so maybe we'll put it in here just to add a bit of weight, so it doesn't slide off the table. That'd be a bit. Okay, I'll refocus. Nice, and we'll try the same process. Please upload. Please upload. Oh, that is so good. And please blink. Yes, look at that. 2 for 2. All right, let's get working on those little Pro Minis now while we've got the confidence. Well, congratulations if you're still here after all of that. But happy days, these guys are running. So I've put them up here to give me a bit of confidence that maybe we might be able to get something happening with this. So there is a website which answers the question, how do I tell which of the many variations of these Pro Minis do I have? And, there's lots of different ways, the markings on the chip, the voltages coming out of the voltage regulator. I mean, that's one thing we could check straight away. There's a light on, which is good. And probably the best way to check the voltage regulator, I think, is to maybe, let's turn this on to 20 volts here, maybe have a look at if I ground this side, so there's my ground here, and then if I look at the various pins on the regulator down here, yeah, that's 5.06. Let me just try the others. 4.48. I'm not getting 3.3s. That's a zeros. That's probably going to be our ground in the middle there. 4.48 and a 0 on the other side. So I'm probably going to say this is supplying 5 volts to the chip quite well. The question is, how much damage have I done, basically? I might pull this off. This is if I can maybe use the hot gun to get rid of that. That says 800 on the top. So we're going to go with 8 megahertz maybe. This SMD. I'll try and get it off there without doing too much damage. And we'll put the 16 on there, and it's a crazy idea given the size mismatch, but we'll see if that doesn't do anything. If that does not do anything, then I might try and put this back on, this SMD chip, and then maybe take this one off and put it in the frying pan here and see if we can't fry its brains and maybe shock it back into some reality. So let's get this off and this on and see if that makes any difference. Whoops. There are 3 pads. That's a little unexpected. And there's our little guy down here, which also has 3 strips on it. So I'm not sure that replacing it with this giant guy down there is going to be doing anything at all. So while I'm here, I'm going to pull off the chip as well. I'm going to put this guy back on and apologize to him and see if we can't maybe, use the high voltage serial programmer to reset this. Bit of a disaster. I bought this guy, 6 years ago, maybe more, from a bloke in Estonia through his maybe Tindy site, which has since disappeared. But there are a lot of these available through eBay, and I think there's a GitHub actually. So I'll try and link that one in as well, which has got a similar product. Some of them have got this dot here in a different location, which does worry me a little bit in terms of why would they turn that around? Is it because this one's wrong? So what I want to do is, to start with, I want to show you how it works. So I've got, let's get 12 volts in here. Okay, so we're going to put, this is a perfectly good A-Tiny 85, but if I whack that in there, I think this is the correct orientation. And what happens is you press this button, reprograms the fuses, and it says it's all good. So that's pretty straightforward, and that has saved me quite a few times. Maybe what I'll do now is I'll use a chip which I know is working. I'm not sure what variety this is. So it's an Atmega 88, so that's fine. And I'll put it with the orientation that it suggests to start with. And I've got a couple of things here to try and keep it secure. The first is just an ordinary old clothes peg. I might actually... There might be a bit of crash editing because, there's been a lot of mucking around with this. It's actually the next day. And in the meantime, I've been trying lots of different things with this. So we saw how the A-Tiny 85 was resurrected in this slot here. I also put in this Atmega 8 So that's a venerable chip in the same form factor as the ATmega328PU, which is the one that goes in here, the 28 pin. And confirmed that, that this worked fine in here. And then I tried some nonsense where I was hooking up, this connection up here, which holds the 32 pin. And I did all sorts of concordance here. I tracked the how the AU matches with the PU and all that sort of stuff, and did some spaghetti. There's been a lot of mucking around that's going on. Finally, though, I did work out one little thing. So in here is the Atmega 88, and that is in the TSOP32 format. And so if I look at this and I press the pin, press the button, I should say, it looks as though it's not working. But if I take out this, which is the HVSP jumper, and press it, lo and behold, I get the green light. So that's a lot of mucking around. Now, I'm still not convinced that this guy here is going to work. And I'm not going to spend 5 minutes umming and ahhing around putting it in there so you can see. So I'll just stop the video there and come back when this is safely ensconced in the same position, because that's a bit of mucking around to get it all in the right position. And we'll see if the same thing applies and I can resurrect this guy from the Pro Mini. Well, I couldn't get this Atmega 328P from the Pro Mini to work, and I've just pulled the other one out, and it is also very reluctant to behave itself. So sadly, I think I'm going to call it. I'm going to take the ESP32s as a win, and I'm going to throw the Pro Minis away and lament what could have been. Thanks for your company again. It's a bit of a long-winded one, and only half the circuit working. I'll see you next time.